on places like the protoplanet Ceres, the largest object located within the solar system's asteroid belt, and one of the scientific targets of NASA's Dawn space probe. And in February of 2017, startling and unexpected news began coming in.
My colleague found a spectral signature in her data that is consistent with, or the same signature of aliphatic hydrocarbons. So here we're finding maybe the building blocks of biological material.
Seen here in red, the organic materials are thought to have originated in the dwarf planet itself. Dawn's study of Ceres also revealed evidence of water and volcanic activity, further raising the scientific profile of Ceres, no longer considered a barren rock. However, Dawn isn't the only NASA spacecraft uncovering new surprises about our solar system. Seven months after arriving in Jupiter's planetary system, the Juno Explorer became fully operational in February of 2017. Astonishing researchers with the steady stream of images and scientific data it's sending back to Earth. Jupiter is by far the largest planet in our solar system, leaving Juno with a whole lot of ground to cover. And although it is the second brightest planet in our night sky, its formation and composition have left us in the dark. Previous NASA missions have given us some understandings of its moons, small dust rings, and atmosphere. But we've not been able to see past the Van Gogh-like swirls of dense red, brown, yellow, and white clouds that paint the planet. At least, not until now. Each individual image is awe-inspiring, especially those captured when Juno came within 5,000 miles of Jupiter's Great Red Spot, the planet's most famous storm. Poring over data from Juno's microwave radiometer, scientists hope to learn more about what powers the tempest and how it differs from other Jovian storms. This critical instrument measures 6 distinct ranges of thermal radiation as it peers more than 300 miles beneath Jupiter's clouds to create a three-dimensional model of Jupiter's atmospheric environment.
So the first time we're looking inside of Jupiter with into the interior, and what we're seeing is that it doesn't work at all like we had predicted. Almost every model that has the interior motion, how the magnetic field, the gravity field, how the deep atmosphere works, it's all different.
Current modeling estimates that the cloud cover is roughly 30 miles thick. Below it, there lies a 13,000-mile layer of swirling hydrogen and helium that changes states from gas to liquid as it nears the center, leading to a 24,000-mile deep sea of metallic hydrogen.
And if we can probe it and work out the abundance of elements in it, hydrogen, helium, the higher elements as well, and work out roughly what that mix is, it'll tell us something about not only how Jupiter was formed, but how the solar system might form.
If there is a bunch of rocky material in the center of Jupiter, it means that in the early solar system, before Jupiter formed, that rocky substances were probably coming together and Jupiter got built around those. It could be that Jupiter was built without any of those and that it just collapsed sort of like the sun and there is no rocky material or core of heavy elements in the center.
Strangely though, gravity data collected so far points to a new possibility. A somewhat larger than previously thought and perhaps partially dissolved core, leaving Jupiter experts with more questions than answers.
We're putting the pieces of the puzzle together, and it's exciting, but we don't have the whole picture yet.
Juno's primary mission is scheduled to continue until February 2018. But this past year, NASA saw another of its extraordinary explorers come to the end.
And we are in the atmosphere.
As the Cassini space probe plummeted into Saturn's atmosphere in a fiery death spiral.
Roughly 1 minute to loss of signal.
The culmination of the craft's revolutionary scientific quest.
Call loss of signal at 115546.
The signal from the spacecraft is gone. Congratulations to you all. This has been an incredible spacecraft, and you're all an incredible team.
She has rewritten the textbooks about Saturn, the rings, the moons, Titan. So many things have changed because of Cassini.
From its launch 20 years ago to its bold grand finale, the Cassini-Huygens mission has unveiled some amazing discoveries. Saturn is ablaze with storms of unimaginable force. The place crackled with giant lightning strikes. The rings are even more dazzling than imagined, stretching across hundreds of thousands of miles. They're made of particles of pure water ice, some microscopic, some the size of mountains.
They break apart and they reform, so there's this beautiful cosmic dance going on inside the rings.
Cassini also carried a little lander called Huygens, which became the first probe to land on a moon other than our own. Its target, Titan, because of its atmosphere.
And as those first pictures came back, we just saw more and more haze and fog and haze and haze, until finally the probe broke through that haze, and we got to see the surface of Titan for the first time.
Huygens landed on the surface of what looked like a mudflat. The surface temperature was minus 350 degrees Fahrenheit, and these pebbles were made of methane ice. The nearby lake, a lake of methane.
Then Cassini went into orbit around Titan and revealed with his radar system that there indeed are lakes of liquid natural gas and other molecules on the surface of Titan. They evaporate, just like here on Earth, create clouds of methane which rain back on the surface, creating rivers of liquid natural gas and lakes.
Could there perhaps be some very interesting life in the lakes on Titan?
But there were dry formations here too, including dunes that stretched for miles and miles, reaching 100 meters high, and 3,000-meter mountains, suggesting tectonic forces at work here, similar to those on Earth. Next, Cassini headed for a close look at Saturn's tiny moon called Enceladus. Here, on the moon's south pole, strange blue cracks, dubbed tiger stripes, 75 miles long and hundreds of feet deep, resemble fault lines here on Earth. Cassini's thermal sensors picked up heat coming out of the ice ball, 200 degrees warmer than the rest of the planet. Cassini then captured giant jets of water spewing hundreds of miles into space from the tiger stripes, shooting out at 1,200 miles per hour, vaporizing and then freezing. Back on Earth, Cassini's stunned controllers quickly reprogrammed the probe to fly right through the jets, collecting particles. And what they found was even more stunning. Organic molecules, the basic building blocks of life.
Enceladus is really special. It's giving us free samples.
Because the geysers are erupting, and they could guide the spacecraft very close and look to see if there's water there, and there is water. Here on Earth, wherever there's liquid water, whether it's deep in the ocean and very hot, or in rocky places or in ice, there's microbial life. So it certainly suggests microbial life could have evolved on Enceladus because it has all the properties that the Earth had when life began here.
NASA controllers plotted the probe's deadly descent into Saturn's atmosphere. Productive until the end. Cassini relayed detailed information about the planet's environment. And then she burned like a meteor and vaporized. Scientists will build on Cassini's contributions as the search for extraterrestrial life continues within our solar system and beyond. Perhaps around the star system 39 light-years away, known as TRAPPIST-1. The first place found, NASA announced, to have multiple planets. 3 here, circling a single star inside the habitable zone, where liquid water can exist.
Well, with this discovery, we've made a giant accelerated leap forward in the search for habitable worlds and life on other worlds, potentially speaking. The TRAPPIST-1 system has really captured our imagination because with this amazing system, we know that there must be many more potentially life-bearing worlds out there just waiting to be found.
Earth-like in size and temperature, these 3 faraway worlds suggest endless possibilities.
The discovery gives us a hint that finding a second Earth is not just a matter of if, but when. These questions about are we alone are being answered as we speak in this decade and the next decades. So I'm really excited about this.
It's been an astonishing year for sure. And as our universe reveals more of its secrets, far out in space and closer to home, our foundation of knowledge will continue to grow, promising ever more to come.